Hello everybody, I'm going to go ahead and jump in to lesson 4.1. So we're going to start with talking about triangles, and we're going to start by classifying triangles by their sides. So the first type of triangle is when we have three sides that are not congruent. So we have no congruent sides. And when we have no congruent sides, we call that scalene. We could also have one set of congruent sides, two congruent sides. And when we have two congruent sides, we call that isosceles. And then we can have three sides that are all congruent. And when we have three congruent sides, we call that equilateral. So that's how we classify triangles by their sides, but we can also classify triangles by their angles. So when we have three angles, and all angles are greater than 0 degrees and also less than 90, we call that an acute triangle. So that's when all three of the angles are between 0 and 90. Now when we have one right angle, we call that a right triangle. So only one of those angles needs to be 90 degrees or right in order for this to be considered a right triangle. Similarly, we only need one angle that is over 90 degrees in order for something to be considered an obtuse triangle. So acute is where all three of them have to be smaller than 90, but right and obtuse, we only need one angle that is right or obtuse. And then we also have where all of our angles are 60 degrees, and we call that equiangular. So equilateral is when all the sides are congruent. Equiangular is when all the angles are congruent. So we're going to start by classifying the following based upon their sides and their angles. So this first one, we have this one right angle. So we would consider that a right triangle. And then we're also given that we have one set of congruent sides. And so because of that, that's going to be isosceles. So it is a right isosceles triangle. What do we think the second one is? So this one has one angle that is obtuse. So this would be considered an obtuse. And then it has no sides that are congruent, so this would be considered scalene. And what about the third one? So the third one, we have all angles are congruent, so we would call that equiangular. And we have that all of the sides are congruent, so we would call that equilateral as well. So equiangular, equilateral. So the next thing we're going to talk about is the triangle sum theorem. And this states that the sum of the measures of the angles in a triangle is 180 degrees. So what that means for this figure is if we took the measure of angle A, we added the measure of angle B, and the measure of angle C. If we added all three of these together, that's going to equal 180 degrees. And this is true for all triangles. So whether they're right, obtuse, acute, or equiangular, all of the angles should add to 180. Excuse me. So the diagram shows the path of the ball in a passing drill created by four friends. We want to find the measure of each numbered angle. So we have a couple of options about what we want to find first. The easiest one would be finding the measure of angle 2. And that's because here we have vertical angles. So that means that the measure of angle 2 is going to be 78 degrees. and that's because we have some vertical angles there. Okay, so then if we know that the measure of angle 2 is 78 degrees, we have a triangle that's formed here. And again, we just said that the angle measures in a triangle sum to 180. So we can say, okay, the measure of angle E plus the measure of angle 2 plus the measure of angle 1 is going to equal 180. So we know that the measure of angle E is 61, and we know that the measure of angle 2 we just found to be 78. So really all we're looking for is the measure of angle 1. So 61 plus 78 is going to be 139, plus the measure of angle 1 equals 180, and then we'd subtract 139 from both sides. So we'd get that the measure of angle 1 is going to be equal to 41 degrees. And then we also have a triangle happening here, right? So we have a triangle here. Oh, that didn't end up like I wanted it to. Okay, triangle here. And so again, this is another triangle. So we can say, okay, well, the measure of angle A plus the measure of angle C. I'm sorry, the measure of angle A plus the measure of angle 3 plus the measure of angle ACB equals 180. Now, I needed to name this ACB, this angle, or BCA, because if I just tried to say angle C, I don't know whether we're talking about the purple triangle or the blue one. So we do need to be careful with our naming there. But then we can substitute in. So we know the measure of angle A is 20. We're trying to find the measure of angle 3, and we know the measure of angle ACB is 78. So we'd combine 20 and 78 to get 98. So 98 plus the measure of angle 3 equals 180. And then we'd subtract 98 from both sides. So we're going to get that the measure of angle 3 is equal to 82 degrees. And then we'll have found all the missing measures. So we're going to the next one. You can start with trying to find 1. You can start with trying to find 2. You have a couple of options here. I'm going to start with finding 2. I'm going to start with this triangle. Maybe. No, that really did not work.
Students, please report to 3A.
Okay, so I'm going to start with this triangle. And again, we know that the measures in that triangle sum to 180. So we know that the measure of angle 2 plus the measure of angle MLK plus the measure of angle LKM is going to equal 180. So we're trying to find the measure of angle 2. We know that the measure of MLK, that's this one, right, is 57. And we know that the measure of angle LKM is 71. So this would be our setup. So 57 plus 71 is going to give us 128. I'm sorry, not 0, 180. So then we can subtract 128 from both sides. And we'll get that the measure of angle 2 is 58 or 52 degrees. Which is great, but we still have to find the rest of the figure. So we're kind of looking at this picture, trying to figure out what's going on. One way we can get an angle real easy is here we have this angle 1, and it's forming a linear pair with that 57. So that means that the measure of angle 1 plus that 57 is going to equal 180. We know because they're forming a line, they're a linear pair. So we can subtract 57, and we can get the measure of angle 1, and that's 123. Okay, which is great, but we still want to find the measure of angle 3. So we have to form another triangle here. And here we can say that that measure of angle 3 plus the measure of angle 1 plus that measure of angle JKL is going to equal 180. Because again, it's a triangle, so all those angles are going to sum to 180. So we're trying to find the measure of angle 3. We just found the measure of angle 1, it's 123. And the measure of angle JKL is 28. So we'd get the measure of angle 3 plus 151 equals 180. And then we'd subtract 151 from both sides. So we'd get that the measure of angle 3 is equal to 29 degrees. I draw a box to kind of try to separate it. Alrighty. So the next one, we got a lot going on. So it kind of depends on where you want to start, but there's plenty of options here. So I'm going to just kind of start here because I see a triangle. And I know that that triangle is going to add to 180 degrees. So I know that the measure of angle 7 plus 58 plus 65 is going to equal 180. So that gives me that the measure of angle 7 plus 123 is going to equal 180. I'll subtract 123 from both sides. And so that gives me that the measure of angle 7 is equal to 57 degrees. Okay. Now, we see that angle 7 and angle 5 are vertical angles. So because of that, I can also find the measure of angle 5. So this tells me that the measure of angle 5 would also be 57 degrees. So we have 5 and 7. We still kind of need to find the rest. Okay. So we can find 4 now. We can also find 6. So we're looking at this angle 6. Again, that's forming kind of a linear pair here. So we know that the measure of angle 7 plus the measure of angle 6 is going to be 180. So again, measure of angle 7 is 57 plus the measure of angle 6 is equal to 180. So we'd subtract 57 from both sides, and we'd get that the measure of angle 6 is going to be 123. All right, we don't have a vertical angle there. But what we do have is we have a triangle over here, right? And we now know what 5 is, so we can kind of figure this one out. Because again, we have a triangle that sums to 180. So we don't know the measure of angle 4. I don't have a ton of room. That's okay. We don't know the measure of angle 4. But we do know the measure of angle 5. We just found that to be 57. And we know that that third angle is 67. So we know that that's going to equal 180. So we can say that the measure of angle 4 plus 124 is going to equal 180. And then we'd subtract 124 from both sides to get that the measure of angle 4 is going to be 56. Now, there are a couple of ways to find this last set, this numbers 8 and 9. So there are definitely a few ways to do that. For the sake of space, I am going to rewrite this one so that I can have a little more room. So there's a couple of ways to write this. So one thing we should maybe notice is that, I didn't want to do that, is that these two angles are congruent. So because these two angles are congruent, we know that they are the same measure. So we actually do have a triangle happening here, right? So we know that these three angles add to 180. And we know the measure of angle 6. I don't have a ton of room. That's okay. That's okay. So we know that the measure of angle 6 and then plus 2, and I'm going to replace that measure of angle 6. We know what that is. We found that already. It's 123. So we know the measure of angle 6 plus, and then we know that these two angles are congruent. So if the measure of angle 8 is equal to the measure of angle 9, they're the same thing. So we can say we have 2 times the measure of angle 8. And that's going to equal 180, right? Because we know that the measure of angle 8 is equal to the measure of angle 9. So we'd subtract 123 from both sides to get that 2 times the measure of angle 8 is equal to 57. And then we divide by 2. So we'd get that the measure of angle 8 is equal to 57 over 2 degrees, which again is also the same thing as the measure of angle 9. Now again, there are other ways that you could have done this. You could have done this big triangle and tried to solve that. You could have done the other big triangle. We have a few options there, but this is kind of the quickest and the easiest. And then we'll have found all of our angles. Alrighty. So we're going to learn a few other pieces. So an exterior angle is formed by one side of the triangle and the extension of an adjacent side. Again, adjacent means next to. Okay? And then we also have remote interior angles. These are not adjacent to the exterior angle. Okay, so what this means is angle 4 is an exterior angle because I can extend one side and that creates that angle 4. So angle 4 is an exterior angle. Okay, and then we can talk about remote interior angles. So this figure has two remote interior angles. And so those are the angles that are inside the triangle, but not next to, not adjacent to that exterior angle. So 2 is adjacent to that exterior angle of 4. So our remote interior angles would be angle 1 and angle 3. Because, again, they're both here. They are on the inside of the figure, but they're not adjacent, not next to that angle 4. And so the reason we need to know this is this has its own kind of properties. So we have the exterior angle theorem, which says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So what this means in this picture is that the measure of angle B plus the measure of angle A, those are our two remote interior angles, they're not next to that exterior angle, that's going to be equal to the measure of that exterior angle. So in practice, we have a triangle here, and we have one side that is being extended. So those are the two remote interior angles because they are not next to that exterior angle. So that means that the measure of angle JKL, that exterior angle, is going to be equal to the measure of angle KML plus the measure of angle L. Again, I can name L with just an L because there's only one angle happening here, whereas over here we have this angle and then we have this angle. So we have to be kind of careful with our naming there. And then we substitute in. So angle JKL is 2x minus 15. And then that's going to equal 50 plus x. So we'll subtract x from both sides to get that x minus 15 equals 50. And then we'll add 15 to both sides. So we'll get that x is equal to 65. And that's great, but we're not quite done yet because it wants the measure of angle JKL. So we need to substitute back in, and it does matter where we substitute into. So we'll do the measure of angle JKL. So we'll do 2 times 65 minus 15. 2 times 65 is 130. Minus 15, we'll get that this is 115 degrees. Alrighty, I'd like you to try number 2 on your own. So again, we have an exterior angle. That is the measure of angle FLW, and that's equal to the two remote or not touching interior angles. So the measure of angle O plus the measure of angle W. Right, again, these are remote interior angles because they're not touching, they're not adjacent to that exterior angle. So then we substitute in. You should do 2x minus 48 equals x plus 32. We would subtract x from both sides. and then add 48 to both sides. So we should get that x equals 80, but again, we're not done yet because it wants the measure of angle FLW. So we want to find the measure of angle FLW. We would plug 80 back in. 2 times 80 is 160, and then minus 48 is going to give us 112 degrees. Excuse me. Alrighty. We've got 2 more. So we're here and we want to find the measure of each numbered angle. So we have a couple of pictures that we can work with. I'm just going to kind of start left to right and see where I get. So we see here that we have a triangle, okay? So we can use, sometimes we use the exterior stuff, sometimes we won't. So in this case, we're going back to that first piece that we learned, which is that the sum of the angles in a triangle add to 180. So the measure of angle 1 plus 52 degrees plus this is a little right angle symbol, that's 90 degrees, is going to equal 180. So we'll get that the measure of angle 1 plus 142 equals 180. We'll subtract 142 from both sides to get that the measure of angle 1 is equal to 38 degrees. Okay, so we got the first one. Now we got to kind of get the rest of them. So I'm going to go ahead and do the big triangle next. So we have this one, because I can use that to get the measure of angle 2, right? I can say that, okay, excuse me. This is another triangle, so I can say that 38 plus 90, because again I have another right angle here, plus the measure of angle 2 is going to equal 180. So 38 plus 90 is 128. And then we'd subtract 128 from both sides. So we'd get that the measure of angle 2 is equal to 52. Alrighty, so we're good there. So we also should see up here, we have this little right angle symbol. So that means that the measure of angle 3 plus the measure of angle 2 is going to equal 90, right? Because they're going to make a right angle. They're going to be complementary. So we know the measure of angle 2 now. We know that it's 52. And so then we can subtract 52 from both sides and get that the measure of angle 3 is equal to 38 degrees. So we're so close. We just have one more, and that is the measure of angle 4. All right. So you can do this a couple of ways. Again, you could do another triangle, or I'm going to do the exterior angle theorem. So the exterior angle theorem that we talked about, again, we know that we have a triangle here. And we know that we have this exterior angle, and we know that it's 90. So we know that 90, that exterior angle, is going to be equal to the sum of the 2 remote interior angles. So that's going to be the measure of angle 4 plus the measure of angle 3, which we just found to be 38. So we can subtract 38 from both sides, and that will allow us to get that the measure of angle 4 is going to equal 52 degrees. Alrighty, again, we use that exterior angle theorem there to get that last piece. There's more than one way to do it, but that's how we got it. Alrighty, last one. We got a lot going on here. So we have a lot of triangles happening, and so we're going to do our best. So I'm going to actually try to go in order. So if I want to find this angle 1, we see that that's an exterior angle. So if I try to use the bottom triangle, I don't know the measure of angle 2, so I can't do much with that there. But I do have a triangle here, and I am given the 2 remote interior angles of this triangle. So that means I can say, again, that exterior angle, that measure of angle 1, is going to be equal to the sum of the two remote interior angles, 32 and 38. So the measure of angle 1 is going to be 70. Okay, once I found that the measure of angle 1 is 70, then I also see that that angle forms a linear pair with angle 2. So that means that 70 plus the measure of angle 2 is going to equal 180 degrees. I can subtract 70 from both sides, and that's going to give me that the measure of angle 2 is equal to 110. All right, so next thing I'm going to try to do is find the measure of angle 3. So this is angle 3. And again, we can do one of those exterior angle theorems here. Again, there's more than one way to find these, but we have a triangle here, and we now know this exterior angle of 2. So we can say that the measure of angle 2, which we just found to be 110, is going to be equal to the sum of the two remote interior angles. So the ones that are non-adjacent, so that's 64, and the measure of angle 3. So we'd subtract 64 from both sides, and we'd get that the measure of angle 3 is going to be equal to 46. Alrighty, we're getting there. So again, there's a couple of options for how you want to find angle 4. I think the easiest one is we have a line that's forming here. So we can say that the measure of angle 4 plus the measure of angle 3 that we just found, which is 46, plus 32 is going to equal 180 because a line is 180 degrees. So we'd get that the measure of angle 4 plus 78 equals 180. We'd then subtract 78 from both sides and get that the measure of angle 4 is equal to 102 degrees. And then we have one more angle we need to find, which is angle 5. And now that we found angle 4, we have another triangle here that we can do. And we can say, okay, the measure of angle 5 plus the measure of angle 4 we just found, 102, plus 41 is going to equal 180. So the measure of angle 5 plus 143 equals 180. We'd subtract 143 from both sides, and we'd get that the measure of angle 5 is equal to 37. Alrighty. So it's kind of like a puzzle. There's more than one way to do it, and we just want to try our best there. So if you didn't get the answers the same way that I got them, there is, again, more than one way to find these. So now you should go ahead and you should do your homework. Have a good day, guys.